a great topic today. We're going to be talking about steel. So we've had previous, Seattle Hub CLF meetings where we've talked about wood and we've talked about concrete and really kind of gotten into the details of all of those. But we really haven't sort of gotten into the details about steel. So this is a great opportunity for us all to sort of learn more and sort of figure out how we can do better at when we're designing with steel. So today we're going to talk about sort of a few different things. We're just going to have a sort of a just general check-in about the Seattle Hub and our communications, but then we're going to dive right into steel. I'm going to talk a little bit about steel design, but the bulk of our sort of talk today is really going to be from the Nucor team. So Nucor, we've got like a great sort of panel from them, from their local Seattle plant, as well as their construction solutions and their corporate division. So they're really going to help us understand more about how steel is produced and really how to sort of tell the differences between them and think about that as we're doing our designs. And then Mark Chen with Skanska is going to talk to us about procuring steel. And so we can sort of figure out how are we going to, now that we have the information about the differences, how are we going to figure out how to implement that in our projects? So I know that sort of some people have been getting the notification sort of emails about our meetings and what's upcoming. So typically on the CLF community webpage, there are sort of a couple days beforehand, there will be posts that will say sort of what's the next meeting about, and remind you about the link and everything like that. But some people haven't been getting that, and I was one of those people. So hopefully this will help sort of the people that are in the same boat that I was in. So if you go to the community sort of CLF page, you go to your sort of little dot that has your initial on it, and you go to the Hub Seattle inbox. There, when you click on that, it'll take you to all the Seattle Hub messages, and there's a gray box here, and that one basically, if you have it set to normal or tracking, it will not email you when there's a new thing there. It only will email you if somebody specifically names you and tags you. So if you want to be getting updates about our meetings, make sure that you have that set to either watching or watching first post. So hopefully that'll help make sure everybody's getting the information that they need. Okay, so diving into steel. So with steel design, there are sort of a lot of different sort of strategies that you can look at to reducing embodied carbon. And some of those strategies are ones that are common to any system that's out there, regardless of whether it's steel or wood or anything like that. And so the biggest thing of that is just looking at your efficiency, right? So architects working with a design group with their structural engineer will look at sort of the efficiency of their system. And if you use less material, it's more efficient, and you're hopefully using less embodied carbon. So one sort of strategy is to roll looking at embodied carbon into that sort of study of looking at the efficiency of your system. How far apart are you going to be setting your columns? How often are you going to be doing your beams and that kind of thing? Another one is base size. So, we've kind of always hear, right? The bigger your base size, if you're going longer, but you're sort of trying to keep your framing to the same depth, you're going to become less and less efficient. And so in that case, you're going to have to use more and more material. So looking at those base sizes is one thing to sort of look at in terms of how that's impacting your embodied carbon. It is important to note, though, that at some point, if you sort of get too small in the base sizes, that may impact your sort of future use. And so you don't want to make it so that your building only works for sort of one use. And if they want to change it somewhere down the line, they say, oh, there's too many columns or something like that. Another one is avoid transfer girders, right? If the best path for once you get a load to a column is to go straight down to the foundation. If you have to sort of take that load and transfer it horizontally, then you oftentimes have to use very deep sort of inefficient sections to get them someplace else. So those are sort of the all systems kind of sort of strategies that you can use. When we look at steel, really one of the things that the Nucor team will really sort of get into in their presentation is talking about sort of what are the sort of ranges of embodied carbon with different steels. And so it's good to sort of consider what that is and figure out if there are possibilities of using embodied steel that has a lower embodied carbon. Andrea's going to talk a little bit later about high strength steel and what the possible impacts are for that in some applications. And then also sort of looking at hybrid systems, right? So are there possibilities for taking, say, your metal deck system out and replacing it with a CLT system? So preserving sort of the long span sort of greatness of steel, but using something else sort of to replace part of the impact. And then the other thing with steel that to always sort of think about is the fireproofing, right? So oftentimes our steel, we need to sort of coat it with fireproofing, which essentially is sort of a cementitious material. And so it's, as we know from looking at concrete, right, that cementitious material has a sort of a big impact. And so sort of really studying if there are ways to sort of reduce the amount of fireproofing that's needed. Although I would say there's no sort of silver bullet sort of fix for doing fireproofing. So when we're thinking about the different sort of steels and their different impacts and trying to figure out sort of which ones are, the cleaner ones or which ones are the dirtier ones, we can start to sort of look at what the impacts are of the different sort of shapes. And so this is what the CLF says about sort of what the typical median GWP numbers are for different shapes. Now, it's important to note that these are based off of North American sort of baselines typically, and then also there can be differences, right? So I think the Nucor team is going to talk about sort of how most of their plants are EAF, so their hollow sections are not going to be the same as these hollow sections here, which are sort of, a lot of them are based off of BOF furnaces. And then the other thing to sort of think about in terms of design is that for steel, most of the footprint is within that A1 to A3. So if you're sort of trying to look for like a quick way to sort of compare and think about what's going on, you can look at the EPDs of the different sort of steel that's out there and use that to sort of really figure out, if I turn this style with the steel deck and then I turn this style with the hot rolled, how much is that going to impact my overall GWP? So that's a good way to sort of compare. And then, so these all that I have up on the screen, those are all ones that are industry averages, but they also, you can start looking at the ones that are specifically for those shapes from different mills. And then, so the important thing to know is that, is that depending upon the shape, not all shapes are made by all the mills that are out there. And so if you have a shape that's a very common shape, there may be many mills that are that produce that. And so AISC, they have this tool that's called the steel availability tool, and you can basically punch in a shape and it will tell you who out there makes those shapes. And so if you punch in your shape and there's a lot of different, providers that make that shape, then you can kind of know that it's probably more likely to easy to get, but then also there's maybe more of a variety of footprints that are out there. Whereas if you look up a shape and it's only provided by 2 or even worse 1 producer, then you may not have that sort of the EPD GWP sort of variety out there to sort of choose from. So I think that's something important to think about as you're thinking about the shapes that you're selecting, and thinking about sort of where they might be coming from, right? And so this is a good way too to see, like, if you're trying to think like, where am I going to get the HSS from, and I want to look up what the possible different manufacturers are, you could look at this up and figure out, oh, here's all these different sort of places where it comes from, and then you could go to EC3 and look up those EPDs to specifically try and figure out what the footprints are from those different mills. And so then once we sort of figure out, what we're going to do, we have to go through and specify the steel. And so there are a number of different options that people have sort of floated out there previously about how to specify steel. One of them could be domestic versus international, because I think the Nucor will talk in a little bit about sort of what the footprints of those two are, and there's definitely a difference between them. That's easy for if you have a project that's already sort of a Buy America project, but if you're not a Buy America project, right, there's going to be a lot of sort of information that you need to have about sort of what is domestic, what is international, and that kind of thing. So it's appropriate for ones that already are in sort of a Buy America but it would probably not be appropriate for one that you're not already in that. There's often been an idea of saying I want it from, an EAF versus a BOF, but there's kind of an information sort of vacuum about exactly where that steel is coming from, because steels, they don't necessarily tell you which kind of furnace they come from. And so it may be hard to actually get the documentation to sort of prove that. Another one is recycled content, right? And that can be one where you can sort of ask for more recycled content, which would mean that it would more likely come from EAF. And then another one that's sort of growing steam and becoming more popular is to specify a GWP limit for steel elements, but you would have to make sure that you're specifying different limits for different sort of types. One thing to sort of note, though, when we're doing specification for steel is that it's a bit different from concrete. So when we do concrete, we sort of know what our market is. We know that in Seattle, we know that all of our major concrete suppliers have the ability to do EPDs. They have type 1L cement. And so we sort of kind of feel like it's an even playing field in terms of the ability to sort of meet the parameters that we're putting out there. But with steel, it's different. And so there is some more of an unknown in terms of number of bidders that are going to be able to fit those sort of profiles. So one thing that I've seen a lot that's kind of to try and account for that sort of unknownness is to put it in as a bid alternate. So saying, give me the EPDs, and then as a bid alternate, provide to me a GWP that's under a certain number. And so CLF has sort of their model specs out there, and that's kind of has some language about sort of how to ask for those EPDs. But the way that the CLF ones are is it's really sort of asking for that information, but then not setting a limit and saying the information that'll be sort of decided later, which works well for, say, a design build project. But for a design bid build project, you'd really want that number to sort of be a defined number and a limit. And so here's a couple more examples of the ways you could do specifications. I stole this one about hot rolled from a presentation that Michael Grunick gave for Tally. And sort of it goes through and it sets a limit for the different sort of shapes. I have another one there for reinforcing steel that I've used before that sort of says for a certain percentage, provide a global warming potential that's under a certain amount. But one thing that you have to sort of really be careful about is, are you doing fabricated versus non-fabricated? And Nucor is going to talk a little bit more about that. And so I think we just want to make sure, we probably are still going to be kind of developing how we're doing this so that we can kind of, as a whole, come together and have sort of consistent specifications. So with that, I'm going to throw it over to Nucor to start talking about steel and how it's produced.